So, we're now going to look at the specialty angles in terms of our trig functions. Specifically, we're going to look at sine, cosine, and tangent of 30, 45, and 60. We're going to derive these from our special triangles, but a lot of people forget everything about the special triangles. So what we're going to do is we're going to take a look at an equilateral triangle. Since we're dealing with the unit circle, our goal is to make the hypotenuse 1. So if this is 1 and this is 1, this whole thing is 1, making these sides a half. Okay. The big thing we're going to need is we're going to need this side, and we're going to use the Pythagorean theorem, c squared equals a squared plus b squared. So if we look at this, 1 squared equals half squared plus b squared. 1 equals a fourth plus b squared. You subtract 1 fourth from both sides, you get 3/4. B squared, you take the square root of that, you get the radical 3 over 2. So this is radical 3 over 2. If we label our respective sides, you're going to see that, oh look, this is 60 because it's equilateral, making this having to be 30. If we transfer this over here to the unit circle, well, this point right here is just going to be, well, how far over is it? Well, that's that distance. It's radical 3 over 2. And then how far up is it? 1/2. Well, that's nice because also if we look at 60, if you transfer that to the unit circle, this point right here, well, it's a little flipped, but as you can see, this 30, it's only a half over. And then we're going radical 3 over 2 up. Now, if you really wanted to think about it, if you just transfer the triangle, this is radical 3 over 2, and then this is 1/2, and you can see the relationship. But now we like to use the unit circle, because we're going to use that idea that sine is the y and cosine is the x. Similarly, if we have an equilateral triangle, and this is, or I shouldn't say equilateral, an isosceles right triangle, and we could decide to call this 1, because I said the hypotenuse is 1, well, what's the missing side? Well, by Pythag, we have x squared plus x squared equals 1 squared. 2x squared equals 1. X squared equals a half. The square root. X equals 1 over the square root of 2, which we know multiplied by radical 2 over radical 2, which is radical 2 over 2. So that's radical 2 over 2 and radical 2 over 2. So this point, well, they're the same over and up. So that's radical 2 over 2 and radical 2 over 2. Okay. Or if you want to think about it, this side is radical 2 over 2 and you're radical 2 over 2 going up. Now, why is this cool? Well, we know that sine, again, is the y-coordinate. It goes cosine of theta, sine of theta. Sine is the y, cosine is the x. Well, if you look, because this is a 30-degree angle, sine is the y. Well, it's just 1/2. Cosine is the x, which is radical 3 over 2. Well, if we look at the middle triangle, there's our 45-degree angle. Well, they're both the same. They're both radical 2 over 2. And then over here, if we look at this one, we're going to again see sine is the y, which is radical 3 over 2. Cosine is the x, which is 1/2. Now, again, if you forget this, remember you can say, oh, this is 1. And remember that sine is opposite over hypotenuse, opposite over hypotenuse. So you can still see this if you forget your unit circle, but you should probably know. Okay. If you remember right here, a 0-degree angle, remember that point was 0 or 1, 0. Sine was the y, so that was 0, and cosine was 1. And up here, this is 0, 1, so this is 1, 0. From there, you should be able to figure out tangent, because we all know that tangent of theta is sine of theta over cosine of theta. Well, 0 over 1, well, that's 0. 1/2 divided by radical 3 over 2. You do copy, change, flip. Cancel, cancel. It's radical 1 over radical 3. If you rationalize it, that is radical 3 over 3. Well, radical 2 over 2 divided by radical 2 over 2. Well, it's the same thing over the same thing. That is just 1. And if you want to do 60, you do the top divided by the bottom. Well, when you do that, you flip the second one, cancel, you get radical 3. Alright? And then, again, the tangent of 90, sine over cosine, 1 over 0 is undefined. Okay. This is our basic 0 to 90 chart. We're going to be using this a lot, so understand, we might want to memorize this. Alright? So, let's do some basic examples of this. Again, pure memorization will help us with this. Okay. The sine of 30, if I go back and look at my chart, sine of 30 is 1/2. So it's 1/2, there we go, times the cosine of 60. And again, the cosine of 60 is 1/2. So if you multiply these two, you actually will get 1/4. Number 2, the sine of 45 squared plus the cosine of 45, the whole quantity squared. These happen to be the same thing, which are radical 2 over 2. Then it tells me to square it. This one is, again, radical 2 over 2, but it tells me to square it. You square that, you square the top radical 2 squared is 2 over 4, plus the same thing, which is 4 over 4, which is 1. Now later on we're going to realize, like, hey, that's interesting. Okay, it actually is always going to be 1 as long as the angle. Sine of 30 squared plus the cosine of 30 squared is also 1. But we'll get to that later. So now, let's take a look at number 3. 4 times the cosine of 30. 4 cosine of 30. Again, if you go back to your chart, it lets me close that. Whatever. Back to this. So back to my chart. Cosine of 60 is 1/2. So there we go. Zoom that in. Plus 3 times the tangent of 45. Now again, do you see why you kind of want to memorize these? Well, the tangent of 45 is 1. So 4 times 1/2 is 2 plus 3, which is 5. Alright. We keep going. Sine of 60. Again, instead of me going through my chart, pure memorization, realize that this is radical 3 over 2. And the tangent of 30 is radical 3 over 3. You multiply, radical times a radical is going to be radical 9, which is 3 over 6, which is 1/2. And skip 4. Whatever. The sine of 30, we said is 1/2, plus the cosine of 30, which is radical 3 over 2. Again, memorization is going to help. You really can't do much to this. If you add the numerators, because they're not alike, you get this, all over 2. And the final question, for number 6, it's 2 times the cosine of 30. Well, the cosine of 30 is radical 3 over 2, plus 4 times the tangent of 60, which is radical 3. Well, those cancel out, and I've got radical 3 plus 4 radical 3. Well, since they have the same radical, you can add those together. 1 plus 4 of them is 5 radical 3. So as you can see, we can use our specialty trig angles to actually figure some stuff out. Now later on in the next chapter, or the next section, we're going to look at what happens if they're not between 0 and 90. They're not one of these. We're going to use our reference angles and such. But the biggest thing is knowing those specific angles. 0, 30, 45, 60, and 90 at least. We should also know 180, 270, and 360. But these are the ones that will come up the most, and you're going to see that we're going to have to memorize them. You take care, and I'll see you in class.